Welcome to the Algebra 1 Semester 2 exam review explanation video. Now, as I go through this video, I may not walk through every problem step by step, especially if they repeat concepts from others, but I will point out all the important concepts and ideas to keep in mind to help you prepare for your final. After you watch this video, if you still have any questions, and after you look through the PDF of the review, please let me know and we can go through it before your exam. So starting with Chapter 6, solving and graphing on a number line. With any inequalities, remember if it's just greater than or less than, when we graph it, we'll have an open circle. If it has the or equal to underneath it, then it is a filled in circle. We also want to make sure if we're multiplying or dividing by a negative that you flip the inequality sign. So for example, in 1, we have x plus 9 is greater than 5. Subtract 9 from each side. X is greater than negative 4. So we'd have an open circle at negative 4, arrow going to the greater than. In 2, subtract 4 from each side, divide by the negative 3, which flips our inequality. So x is less than or equal to negative 4, so a filled in circle at negative 4 going to the negatives. So then 3 and 4 are the same idea, so I'm not going to walk through those. You can see each step. 5 and 6 will have two different answers. We want to set them up to solve them separately. So in 5, we'd solve the 7v minus 5 is greater than or equal to 65 to get v is greater than or equal to 10. And then we'd solve the negative 3v is minus 2 is greater than or equal to negative 11. So add 2, divide by the negative 3, flip the sign, and v is less than or equal to 3. So then filled in circles at 10 and 3, arrow off at 3 is going less than, arrow off at 10 is going greater than. With 36, we have negative 36 is less than 3p minus 6, which is less than negative 15. So whatever we do to the middle, we have to do on both outsides. So we'd add 6 to start to get p alone, divide everything by 3, and we'd have negative 10 is less than p, which is less than negative 3. So then it'd be open circles at negative 10 and negative 3, and the segment connecting them. With absolute values, you want to make sure you get whatever's in the absolute value alone first, and then we would take, for example, in this one, the absolute value of p plus 4 is less than or equal to 8. It would be p plus 4 is less than or equal to 8, and p plus 4 is greater than or equal to negative 8. Same here. First, we need to add 3 on each side to get the absolute value x minus 2 is greater than 8. So then x minus 2 is greater than 8. X minus 2 is less than negative 8. Solve both and you would graph them, which you can see here. So just be careful with the absolute values that you get them alone first, and then set it up for both the positive and negative. Graphing inequalities. If it's less than or greater than, we have a dashed line. Greater than or equal to, less than or equal to, we have a solid line. Then x is less than negative 2, dashed vertical line through negative 2. Shading would be to the left because all those values are less than. In 10, y is greater than or equal to 2/3 x minus 4. So slope-intercept form, start the graph with the y-intercept at negative 4. And then it would be up 2, right 3. Up 2, right 3. Draw your solid line, and then shading y is greater than or equal to 2/3 x minus 4. So if we put in the point 0, 0 to check where our shading is, it would end up being 0 is greater than or equal to negative 4, which is true. So we would shade above the line towards 0, 0. And then 11, an inequality word problem. We know our total amount of money is $125 and each shirt is $20. So 20 times x, x being the number of shirts, is less than or equal to 125, the most we can spend. Divide by 20, and x is less than or equal to 6.25. Well, we can't buy a quarter of a shirt, so 6 shirts could be purchased. Chapter 7, solve by graphing. For the first part, now just a reminder, what I think is the easiest form to graph is slope-intercept, y equals mx plus b, where the b is your y-intercept, the m is your slope. So both problems in one are in slope-intercept. So for the first line, y equals 1/2 x plus 4, go up 4, slope up 1, right 2, up 1, right 2, draw your line. Other line, y-intercept in -2, slope in -1. So start at -2, slope down 1, right 1, down 1, right 1. Draw our line, and we can see there's one solution where they cross at -4, 2. In number 2, I rewrote both equations in slope-intercept form. Both are y equals x plus 3. So that means we end up with the same exact line, telling me we have infinite solutions. And then in 3, rewrote the bottom equation into slope-intercept to get y equals 3x minus 7. Graph both lines, same slope, different y-intercept, meaning they're parallel, so they will never cross, so there is no solution. Now we get into solving a system of equations with substitution. So to use substitution, you want to remember you need to get one of your variables alone. So in 4, we already have y alone, y equals x plus 2. So we're going to take x plus 2 and put it into the other equation for y. So that equation becomes 3x plus 2, then in parentheses, x plus 2 equals 9. So we have to distribute this 2. So we have 3x plus 2x plus 4 equals 9, which would be 5x plus 4 is 9. Subtract 4, divide by 5, and x equals 1. Now I'm going to take the x equals 1, put it back into this top equation to get y. 1 plus 2 is 3, so y equals 3. So we would have one solution at the point 1, 3. Number 5, I want to get x alone in the top equation, so I'd add 4y. So x equals 4y minus 4. Take 4y minus 4, put it into the bottom equation for x. So we'd have 3 times 4y minus 4, in parentheses, minus 12y equals -12. Distribute the 3. 12y minus 12 minus 12y equals -12. Well, 12y minus 12y cancels. So we have -12 equals -12, which is true. So if the variable cancels and our equation's true, we have infinite or infinitely many solutions. If it would cancel and it's not true, so if it said like 7 equals -12, then we'd have no solution. 6 and 7, we're using elimination, so we want to multiply one of the equations by a value that will allow one of my variables to cancel. So in this case, if I decide to cancel the x's, I multiply the top equation by -1, making it -2x minus y equals -6. Add that to the bottom equation, x's cancel, and we end up with 2y equals 4. Divide by 2, and y is a positive 2. Then substitute that back into either of the original equations for y. I put it into the top equation, so 2x plus y equals 6. So 2x plus 2 equals 6. Subtract 2, divide by 2, and x equals 2. So we'd have one solution at 2, 2. In 7, multiply the top equation by -3, and we end up canceling out both the x and the y's. So I have 0 equals -12, which is not true. So in 7, we would have no solution. Then in 8, a word problem. Student tickets are $3, adult tickets are $5, and our total amount of money was $14.50. So 3x plus 5y equals $14.50. Then we know we sold 350 total tickets, so x plus y is 350. I decided I wanted to use elimination, so I multiplied my x plus y equals 350 by -5, so that way I can end up canceling out my y's. So that gave me -5x minus 5y equals -1750. So right here, use my combination elimination, and I end up with -2x equals -300. Divide by the -2, and x is 150. Then x plus y equals 350, so subtract our 150, and y equals 200. Matching the best options here. If they're both in slope-intercept form, best option is to graph. If they have x's and y's, one of them's already alone, like in 11, we'd want to use substitution. And if neither x or y are alone, we'd use elimination. Now, graphing the system of inequalities, remember the greater than or less than are dashed lines, less than or equal to, greater than or equal to are solid lines. Then, after you graph your lines, you want to check the shading. So I always put in the point 0, 0. So for example, in 12, put a 0 in for x and y, and we end up with 0 is less than 5, which is true. So yes, we would shade towards 0, 0, or below this blue dashed line. In the bottom one, put in 0, 0, end up with 0 less than or equal to -3, which is not true. So with the pink line, we would shade to the right or away from 0, 0. So our shaded region is right down here. 13, 3 different lines to graph. Our shading ends up in this triangle in between. And then writing our system of inequalities, we'd want to figure out our y-intercepts of each line, here and here, figure out the slopes, and then figure out our signs based on the shading. Chapter 8, Rules of Exponents. So now remember, exponent times an exponent. So like y to the 8th times y to the 3rd, we add the powers. Then, with the coefficients out in front, we just multiply as normal. Anything to the 0 power is 1, so then we'd have a -4a to the 6th. With 3, we'd have to simplify the 2p to the 7th to the 4th. So 2 to the 4th is 16. P to the 7th to the 4th, we'd multiply the powers, giving us p to the 28th. Then p to the 6th to the 5th is p to the 30th, giving us 16p to the 58. With 4, we can simplify 18 over 54 to 1/3. Division of the powers, we'd subtract, so that gives us n to the 8th. And m to the 2nd over m to the 6th gives me m to the 4th on bottom. Anything to the negative power, we flip it side of the fraction. So this just becomes b to the 9th over a to the 4th. In 6, we'd want to multiply first across the top and across the bottom. So then I have 70 a to the 3rd, b to the 5th, over 70 a to the -4th, b to the 11th. 70s cancel, a to the -4th comes to the top, so I'd have a to the 7th over b to the 6th. Then in the next few here, you can just see the work and the different concepts. Just be careful in number 9. Because the whole thing's to the negative second, I flipped the whole fraction first, then went to the second power. Graphing the exponential functions, I always put in a -2, -1, 0, 1, and 2 for x. Use your calculator to get the y values. So in 10, we have a graph coming down left to right with a curve. In 11, it's going up left to right with a curve.